Today we're doing 8th grade, Chapter 1, Lesson 5, Roots. Specifically, square roots and some cube roots. But first let's start with square roots. That is one of the two equal factors of a number undoing squaring a number, such as 5 squared means 5 to the second power, which equals 25. Square root means one of the two equal factors of a number undoing squaring a number. For example, 5 is the square root of 25. Think about area, and area has to do with length times width. So if we had a perfect square, and I'm sorry, mine's not perfect, to find the area of a perfect square, we would multiply both sides. So if both sides were the same, we might have 5 times 5, which is 5 squared, and 5 to the second power, or 5 squared, is 25. When we find the square root, we're undoing that. We're like going backwards. So the square root would just be 5. Every positive number has both a negative and a positive square root. Every positive number has both a negative and a positive square root. Because think back to my little example. If I multiply negative 5 times negative 5, I would still get positive 25. Or if I multiplied 5 times positive 5, I would still get a positive 25. The symbol that we use to show square root is called a radical sign. A radical sign is used to indicate the principal square root. And it looks like this, kind of like a division sign, but it has this little catch right here, a check mark with a division sign, a radican. Example 1, 2, and 3, we're going to determine the square root. So we're trying to find the square root of 36. What times itself gets me 36? Well, 6 times 6 gets me 36. So 6 is the square root. Well, this one's a little bit trickier because it has a decimal. So think of it without a decimal. What would be the square root of 144? What times itself equals 144? Well, 12 times 12 equals 144. So this one would equal 12. If we need a decimal, there's 2 spaces behind the decimal, so we need half of that. So we need the decimal to go over 1 space. Remember, we're going to multiply 1.2 times 1.2. So it would be 2 spaces behind in the answer. So we're looking for half of the spaces. Next one, it's a fraction, and it's got a negative sign on the outside. So it still needs to be a negative sign on the outside. And then what would be the square root of each number? So the square root of 9 would be 3, and the square root of 64 would be 8. Because 3 eighths times 3 eighths would be 9 64ths. And then we have this one, example 4, determine each square root. Okay, this had the negative sign on the outside of the radican. This one has the negative sign on the inside. Is there any two numbers that we could multiply together, the same number? It'd have to be the same exact number that we could multiply together and get a negative. Well, we could multiply 4 times 4, and that would get me 16, but I need a negative. I could try negative 4 times negative 4. That would still get me a positive 16. So when we're taking the square root, that means one number times itself. There is no number that's going to equal a negative. So there is no real square root because no number times itself is equal to negative. Now let's shift gears for a little bit. That's square root. That's two sides. What about cube root? Think of a cube. You know, when we're finding cubes, that's usually volume. Cube root. And when we do volume, that would be length times width times height. 3 numbers. So cube root is one of its 3 equal factors. For example, what number times itself 3 times would be 125? 5 times 5 is 25. Times 5 again would be 125. So the cube root is 5. Okay, now here we go again with a negative sign on the inside. So is there any number times itself 3 times, then we could still get a negative? About if I multiplied 3. 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. That's still positive. What if I had negative 3? Negative 3 times negative 3 would be positive 9. Times negative 3 again would be negative 27. So with cube root, we can have negatives on the inside. This could be some very good information for you to copy down. If you're not using a calculator, then finding square root or cube root can be a little bit difficult. So these would be very good for you to copy down into your notes. Let's talk about the worksheet you're supposed to do today. The independent practice. For 1, 2, 3, 4, and 5, you are finding the solution. And if there's no solution, like we talked about, you can't have a negative sign on the inside if you're doing square root, then you just write no real solution. Okay. Let's look at number 4. What would be the square root of 121? Because remember, you take the square root of the numerator and then the square root of the denominator. What number times itself equals 121? 11. So 11 is the square root. And what times itself equals 169? 13. So the square root of 121 over 169 is 11/13. Number 3 is a cube root. Number 7 says solve each equation and check your solution. So if we're trying to figure out h squared, which means h times h equals 121, what times itself would equal 121? Basically what you're doing is finding the square root of 121. The same thing over here for number 9. You're just finding the square root of 81 over 144. Number 10, Moesha had 196 pepper plants that she wants to plant in square formation. How many pepper plants should she plant in each row? So you're trying to find the square root of 196. If you use the list that I showed you, this page won't be too difficult.